This lesson is the second part of graphing motion. Let's look at a displacement versus time graph. If we want to interpret the displacement, it's relatively easy. We just have to read the graph. So what is the object's displacement at the end of 7 seconds? Well, we find 7 seconds, we read up and over, and we see that it's 5 meters. What's the object's displacement at the end of 11 seconds? Same thing. What we need to be able to do is look at a displacement versus time graph and instead interpret velocity. From a displacement versus time graph, the velocity is the slope. What is the object's velocity for the first 5 seconds? So let's calculate the slope of this segment of the graph. Slope is the change in the y value divided by the change in the x value. In this case, it's 5 meters minus 0 meters over 5 seconds minus 0 seconds, giving us a slope of 1 meter per second. What is the object's velocity from 5 seconds until 10 seconds? Well, we don't really have to do any math here. A horizontal line, you might remember, has a slope of 0, which means the velocity is 0. Let's look at one more example. What is the object's velocity from 11 seconds until the end? Once again, we'll calculate the slope. And we get a slope of negative 2 meters per second, and therefore a velocity of negative 2 meters per second. Now let's look at a velocity versus time graph. If we simply want to interpret the velocity, like before, it's relatively easy. We just read the graph. What's the object's velocity at the end of the first second? Well, find 1 second, go up and over, it's 4 meters per second. What's the object's velocity at the end of 3 seconds? Same thing. It does get more difficult, like before, if we want to interpret something else from the same graph. Let's say we want to interpret the acceleration. Well, just like we found velocity from a displacement graph, we can find the acceleration from a velocity graph by calculating the slope. So what is the object's acceleration during the first 2 seconds? We're not going to bother doing any math because we can see that the slope of this segment is 0, giving us an acceleration of 0 meters per second squared. Of course, you can also see that during this time period, the object did not speed up or slow down. What is the object's acceleration from 2 seconds to 4 seconds? Let's do the slope calculation. Remember that slope is the change in y over the change in x. We end at 0 meters per second. We originated at 4 meters per second. And this happens from 2 to 4 seconds, and we get a slope of negative 2 meters per second squared. That is the acceleration during this time period. From this same graph, we can also interpret the displacement. This is going to seem strange, but to determine the displacement from a velocity versus time graph, we calculate the area. If we want to know the displacement during the entire 4 seconds, we need to calculate this area. Now, technically, this shape is a trapezoid, and there's an equation for the area of a trapezoid, but I don't remember it off the top of my head, and it's not in your reference table, so instead, we're going to break this shape up into familiar shapes. We'll start with this square or rectangle. The area of a rectangle is length times height. We have 2 seconds of length times 4 meters per second of height, and we can see that the area of this segment is 8 meters. The other part of this shape is a triangle. You'll remember, I hope, that the area of a triangle is the base times the height divided by 2. We have a base of 2 seconds. Look carefully, from 2 to 4 seconds is a base of 2 seconds, a height of 4 meters per second, and we divide that by 2 to get an area of 4 meters. Now we simply add those up and say that the displacement of the object during those 4 seconds was 12 meters. Let's summarize. On a displacement versus time graph, the slope equals the velocity of the object. On a velocity versus time graph, the slope equals the acceleration of the object, and the area equals the displacement of the object.